In this demonstration, I'm going to show how you can add your own user-defined or logical, sometimes known as business logic or functional code, to the source code of the model and the powerful features that are built into SpectraCX to make it a complete round-trip SCA engineering environment. At this point of waveform development, we've done all of our graphical modeling of our SCA components. We've built our application, wired it together, and we've used SpectraCX to generate source code, SCA artifacts, and to build that source code into executables, which could certainly be deployed on an SCA platform. However, they are essentially empty resources without any functional code inside those resources. So now we need to add some functional code to be able to do something with the data that's coming in and out of those resources and to be able to control those resources. So whilst it's tempting for users to go down into the source code files, which we showed you earlier in here, this is not necessary with SpectraCX, because what we've done with SpectraCX is we've worked to provide you with a complete round-trip SCA engineering environment, which means that you can stay working with the model right through the life cycle of your development. So what we now do is we go to our production waveform package, we open up that package, and we go to the SCA resource where we want to add our user code. We open the diagram, in this case the upper layers resource diagram. This shows the resource that we created with our user ports and our functions for this SCA resource. To be able to add user code to any one of these functions, I simply select a function and I open Editor. What this does is it opens the worker.cpp file and puts my cursor between these two tags, the CXGen user region begin tag and the CXGen user region end tag. And so I can put between these tags, I can put my functional code. Some people might call this my behavioral code. Some people may call it logical code. I can put my source code in here. I can either put the code in by hand. I could potentially have code that is generated from some other tool, and I could copy that code into this area, and then I close the source file, and that then updates the source code. And this is very, very important point to make, that source code is now stored within this model. To prove that source code is there, I can select that function I was just working on. I can open the editor again, and I can see that my functional code that I placed in my source file before is there. Now, to further prove the point that the source code that I've added to my model is in fact stored in the model, let's for a moment move over here to the Project Explorer. We'll go down to the Components folder, and on the upper layers resource, let me just delete all of that source code that's sitting in the generated source area. We can see that that folder has now disappeared. I can go up to my production waveform application, and then I can regenerate the source code. wait for a moment while that generation is performed by SpectraCX, and then let me go back down into the components folder. We can see the upper layers folder has been regenerated here, and that the upper layers worker.cpp file is there. And then if I work my way down to about halfway, I think, here I can see that source code that I put in by interacting with the model component is still within the source code, and that's because the source code is actually merged within SpectraCX and stored inside the model. So it's not stored externally like out in this area here. This is just a copy of that generated code, and so that importantly avoids any loss of code should you, say, accidentally delete these files here. And so once your code is stored within the model, it can be regenerated at any time. Okay, well, another thing that you may be concerned about is what would happen if I was to make a change to my model. Let me say I might add another user port to my model. What happens to when SpectraCX then regenerates the code? Does it destroy the user code that I've added? Well, let's just demonstrate what takes place. So let me grab a user port, well, a port. Let's add that to our upper layers interface. Let's search for the high-speed data interface, and let me add a new data port. We'll select that new data port. We'll go down to SCA, set the kind to data so that we don't cause any SCA errors. And now that I've changed my model, let me save that model, and let me regenerate the code for this model. I've regenerated the code. Now let's have a look into that start function. Let's open our editor and check to see if our source code is still there. And there it is. So even though SpectraCX is regenerating the code for new SCA components and generating a new upper layers worker.cpp file, it is keeping intact the source code that I've added to my project and effectively merging that code so that it is not lost. And that's a very, very important and very powerful productivity feature of SpectraCX, where we provide this complete round-trip modeling environment, which means that you can stay working here with the graphical model, and the model can stay the source of your project at all times, and you do not lose synchronization between the model and the artifacts that are used to build your executables. That completes this demonstration showing how you can add user-defined logical, business logic or functional code to the source code in your model project.